learned in the module on graphing straight lines how to plot a graph of the solutions to a linear equation containing two variables. We did it by finding the coordinates of at least 2 points. And we did that by picking a value for x and solving for y, or by picking a value for y and solving for x. Either approach works fine. If we pick x equals 0, we find that y equals 4. That can be represented by the coordinates 0, 4. If, instead, we pick y equals 0, we find that x equals 8 over 3. We have a second point with the coordinates 8/3, 0. So far, no surprises. If you didn't follow how we did these two steps, be sure to go back to the module on graphing straight lines before continuing, because graphing a straight line is key to all we're about to do. We take the 2 points we just found, locate them on our Cartesian plane, and draw a line through them. This line is the graph of the equation 3x plus 2y equals 8. Let me point out a couple of things worth remembering here. First, the 2 points that we calculated have special importance because they lie right on the axes. For that reason, we give them special names. 0, 4 is the y-intercept, 8/3, 0 is the x-intercept. The straight line graph crosses the two axes at the x and y intercepts. Second, a little bit of magic happens when you solve for one of the variables. If you need it, review the module on solving formulas, and then solve for y. Look closely at the answer and notice that the number standing alone, the 4, is in fact your y-intercept. When x equals 0, y equals that lone number. We saw it on the graph a moment ago. And that always happens when we solve for y. Solve a linear equation for y, and the number sitting alone will give you the y-intercept. This is a very useful idea. We can write it as a rule to remember. Try this one by yourself. What is the y-intercept of y equals 17x minus 13? Pause the program, and when you have the answer, click play again. This equation is already solved for y, so all you have to do to pick out the y-intercept is to read the number that stands by itself, negative 13. That's right, don't forget the negative sign. The line of this graph will cross the y-axis 13 units below the origin. So we can easily answer the question, what is the y-intercept? Here's a harder question. Does the other number, the 2 in the 2x, tell us something? The answer is, let's go skiing. A skier will tell you that there are 3 kinds of slopes. One kind doesn't work at all. Whether you're going up or down, the skiing is very brief. We call that kind of slope a cliff. Another kind doesn't work very well either, because you do all the work, no matter which direction you're headed. We call it a flat plane, or the flats. A third kind is much more useful. It's easy to go up if you happen to have a chairlift under you, and it works even better going down, because that's what skiing is all about. All of these are called slopes, the cliffs, the flats, and everything in between. Now let's go back to that simple little equation we were looking at. Remember our question? We know that the positive 1 is the y-intercept, but what does the 2 represent? The 2 gives us the slope. If we graph the equation, the 2 tells us how steep the resulting line will be. When we change the value of x by 1 on the x-axis, we must change the value of y by 2 on the y-axis. We can see that by reading the numbers in brackets that specify each point in succession along the line. While x goes from 1 to 2 to 3, y jumps from 3 to 5 to 7. So the 2 in the 2x tells us how much y changes for a given change in x. 2 over 1, or 2 to 1, is the slope of this line. And notice that we read it y first, with the y on top. Y over x, 2 over 1. Think of a steep hill, a ski run with a name like Widowmaker or Catastrophe. It's got a very steep slope. What does that mean? Lots of y for very little x, maybe a slope of 2 or even 3 to 1. Think of a shallow hill, a beginner's run, the bunny hill. Very little slope here, maybe 1y for every 2 or 3x, just enough to keep you moving. We can formalize our thoughts about slope in a definition. Slope is the ratio of how much y changes compared to how much x changes. Let's go back and take another look at the graph of our equation, y equals 2x plus 1. The 1 is the y-intercept, and the 2 in 2x is the slope. Compare the 2 points on the line and you'll see that y is changing faster than x. Faster, in fact, by a ratio of 2 to 1. We can turn these ideas into a general statement like this. This statement is pretty specific. It only applies when the equation is solved for y. Y must stand alone on one side of the equation. Here's a problem to try on your own. It doesn't look like our last example, but here's a hint. Remember to solve for y first. Pause the program now. When you have the solution, click play again, and we will work it out together. This is a linear equation in 2 variables. I know its graph will be a straight line. As I hinted, the first step is to solve for y. With the y by itself on the left, the equation is now in slope-intercept form. Y equals -3/2 x plus 4. The first part is easy. 4 is the y-intercept. But I read the slope as -3 over 2. What does that mean? A negative slope? Let's look at the possibilities. A positive slope goes up from left to right. Every increase in the value of x results in an increase in y. And the higher the number, the steeper the slope. A slope of 1/2 is shallow. A slope of 3 or 4 is steep. A negative slope goes down from left to right. Every increase in the value of x results in a decrease in y. It can be just as shallow or just as steep as a positive slope. In between the positive and the negative is a unique slope, a slope of 0, a hill that's flat. Because y never changes, the line is horizontal and the slope is a plateau. A 0 slope is named by its y-coordinate only. For example, y equals 3. A second unique slope occurs when it's the x that remains unchanged, and the slope is totally vertical. We call it an undefined slope and name it by the x-coordinate. Or, as we did earlier, we might call it a cliff, an undefined slope with an undefined pile of skier at the bottom. That's all there is to it. When we're given a linear equation in 2 variables, we know how to figure out the slope. We just solve for y and then read off the y-intercept and the slope. Question: if we didn't have the equation, just our line, could we find the slope? Sure we could. Remember our definition of slope. All we need are the coordinates of any 2 points so that we can find the change in y and the change in x. How? By subtraction. We subtract one set of coordinates from the other. It doesn't matter which 2 points we use as long as we do x and y in exactly the same way. Y first, 7 minus 4, then x, 5 minus 1. Divide the change in y by the change in x, and we have what we're looking for, the slope. In this case, 3 over 4, or 3 units of y for every 4 units of x. We can reduce this process to a formula. We will name the variable for the slope m. To find the slope of a line joining 2 points, subtract the y-coordinates, then subtract the x-coordinates in the same order, and divide. Notice how the coordinate variables have subscripts 1 or 2 as an aid to tell us which points we're talking about. Use the formula to solve a problem on your own. Find the slope of the line joining these 2 points. Pause the program while you work out your answer. When you're ready to compare solutions, click play again.